Hey everyone, thanks for joining us for the next session of our Spotlight on GitHub Advanced Security series. Level up application security on Azure DevOps. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. And while we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand within 24 to 48 hours right here on the Microsoft Reactor YouTube channel. With that, I'll turn it over to our presenters today. Thanks so much for joining us.
Thanks for joining, everyone. My name is TJ Corrigan. I'm a cloud solutions engineer here at GitHub, and happy to share with you a little bit about GitHub Advanced Security on Azure DevOps. With me is Laura.
Hi, I'm Laura. I'm a product manager over on the Microsoft side working on GitHub Advanced Security for Azure DevOps. Super happy to be here with you all.
And yeah, thank you for joining this overview. Today, we're going to walk through a brief overview of advanced security on ADO, or you'll hear me call it GHAzDO for short. So I'm going to run through a little bit of slides here, and then we're going to jump over and actually show you a live demo of all the features. And then we'll hand it over to Laura to talk a little bit about her roadmap and certainly answer any questions that might arise in the chat, or if we have any live questions as well. First off, I just want to give a little background around sort of application security and why we think it's so important and have made this available inside of Azure DevOps. And that's really because despite all this effort that we're spending and collectively the industry is, we're finding that security threats are continuing to rise. So as we write more and more lines of code, we're writing more and more vulnerabilities. So to kind of steal the old COVID analogy, our goal is really to figure out how do we flatten that curve? How do we make it so that as we're writing more code, we're writing less vulnerabilities per line of code? And we really think to do that, we need to kind of take a different approach to it, to security, and try to figure out how we can make it really seamless for developers, easy to use, so that ultimately we can get better and sort of try to pay down some of that security technical debt. And of course, what we find is that there's still a lot of vulnerabilities out there. And many of those are happening through really easy things to detect. Things like leaked credentials or vulnerable components that you might be using, like an open source library, are both common patterns for vulnerabilities in your own applications. And our goal is really to figure out how do we shift, from the idea of sort of getting caught late, with a breach, and how do we catch these things as early in the development process as we can, where it's still cheap and easy to fix. With only a couple of clicks, we can fix a problem before it ever sees a running environment and ever really presents a risk to our organization. But as an industry, we've been talking about this idea of shifting security left for a long time. So it's really, the thing is, it's a little bit easier said than done. And what we're seeing is that teams are struggling to sort of scale with security. The average organization has something like one security team member for 100 different developers, and this sort of idea that this is a security team problem can't really scale. As I mentioned, we really have to make it part of everyone's job. All the developers become members of the security team and feel empowered and enabled to help manage the application security. And of course, one of the things we want to do is empower women with the tools and the knowledge to do so. And that's why we've really brought advanced security directly into ADO. And that's our idea, is really trying to partner together. So bring the security team, the developers all in the same boat, and help them sort of paddle in the direction of improving their application security. And the way we've done that with advanced security in Azure DevOps is to really bring the tooling right to where developers live and build it really native into their development workflow. So rather than having to go and sort of look at a PDF report that I might get once a month or something like that in my email box, we're trying to bring it right into the path of where developers are working. So I'll show you a little bit later. When I open up a PR, I'll get notifications right then when I might be introducing vulnerable code. So I don't, as a developer, have to go and make extra clicks, so we can put it right in their path and make it really easy and natural for them to interact with security, rather than something that's sort of that afterthought or sort of compliance gate that might happen right before they do a release. And really, when I'm talking about advanced security, there's three main components here. We have code scanning. That's the code your developers are writing themselves. Secret scanning, looking for hard-coded credentials. And then dependency review. That's the sort of open source components that are getting brought in from external sources. That's the main components of advanced security. But obviously, we're part of Microsoft and a suite of much larger security solutions. So we can certainly play nicely with Microsoft Defender for sort of a full CSPM sort of solution. But yeah, I'll also show you integration for that a little bit later too. But know that this is just focused on the application security section today. But know there's lots of other solutions out there for sort of holistic sort of cradle to grave for security. Oops, sorry. Focusing on the components inside of advanced security, I'm going to start with secret scanning. This is probably the easiest to talk about, and it's one of those sort of low-hanging fruits. Think of it as any sort of password, credential, that sort of thing might be stored inside of your code. Today, we're able to basically work with several hundred different partners to detect several hundred different types of secrets. So we're not just doing like a regex search for, alphanumeric strings of 32 random characters of high entropy. Instead, we've worked with these partners to exactly build matches for their particular type of secret, so that we can get sort of that 100% accuracy of detection. And we can do more than just detect these sorts of secrets. We can also use what we call push protection to stop them from showing up in your repository in the first place. So if I have a new secret, try to check it in my code, you'll see it'll basically get blocked before it ever hits the server, before it's ever sort of made available outside of my individual computer. So we're seeing that has a huge impact of sort of preventing these things from ever happening in the first place, that ultimate sort of shifting security left sort of idea. And I'm going to demo all this in just a few minutes. Here's just a few lists of partners that we work with for secrets. Obviously, the Microsoft ecosystem is highly covered, but we're happy to work with a wide variety of partners, all the other major cloud providers, as well as many other sorts of third-party development tools that might have things like API keys or credentials that you might have in your code. The next component I want to mention is dependency scanning, or you might think of this as SCA or supply chain analysis, where we're looking at all the things that get brought in. So the average project, something like 80–90% of the total lines of code are not actually written by your developers, but are being pulled in from the open source community. Those libraries are also sort of think of it as a shared access point. So as an attacker, I could find a vulnerability in one library and use it in hundreds or thousands of applications. So it prevents a really sort of attractive footprint for developers to get a foothold in your org. So what we do is at build time, we'll look at all the things that are getting pulled into your project. So not just the dependencies listed in your Maven POM file, but we'll actually find all the transitive dependencies and everything that's getting pulled in and incorporated into your project. Once we have that sort of bill of materials, we can compare that against our advisory database to detect whether or not you're using any components that have known vulnerabilities out there that it could be exploited in the wild. And we'll bring those to your attention. So again, I'll show what this looks like in just another minute. The last component is what we call code scanning. Think this as a SAS tool or static code analysis, and is powered by our engine called CodeQL. And it works a little differently than some other things out there in the market, in that we're actually doing sort of a full semantic analysis of your code. So we don't just look at the built binary at the end or sort of just look at your source code. We can actually hook in at compile time to understand how your code is going to execute in the wild. It lets us build basically a database or a graph of how your code is going to run. And then we can sort of query that to look for vulnerable execution paths. So again, the goal here is to really reduce the false positive rates and make sure we're only detecting things that are truly exploitable. So just because I have a code smell doesn't mean if there's not a path to actually call that method or pass tainted data into that method is only when it can be exploited. So that lets us really sort of narrow down in on those key things that your developers need to address in hopes that they can spend less time sort of triaging and marking things as false positives or won't fix, and instead give them just the things that they really should go out and tackle. Those queries are written by GitHub, but as well the open source community at large. So generally speaking, we can stay very up to date as new and emerging threats are out there. You can generally see new queries and things being written in as little as 24 hours. So that's what I wanted to actually sort of talk about on the slides. And now I'm going to jump over and actually show what this looks like in a real ADO project, because that's probably way more interesting than watching some of these slides. So I have here pulled up a sample ADO project. This one, let me make this, sorry, go away so I have a little bit more real estate on my screen here. So this one is just basically a sample Java project that I have loaded in here. If anyone who's familiar with OWASP, this is actually a project they have provided called the WebGoat project. It's a deliberately vulnerable application, so I can actually showcase a few different sort of findings inside this environment without actually writing any vulnerable code myself. So thanks to the OWASP community for this library. But yeah, this application here is a Java-based application, but we can work with a wide variety of different software languages with our engine. And the first thing I want to show before I go too much into the features of advanced security is really just how easy it is to turn it on. The best security tool in the world doesn't really do you any good if it's not actually running scans of your environment. So we've tried to make it as easy as we can. So if I come into my project settings here, I can do this at 3 different levels. So I can turn it on at my individual repository. I can do it at the project level. Or I can do it at the entire organization to cover my whole real estate. So I'm going to show you the project level here. So if I go into the repos for my project, under the settings, you'll see there's a section right up top for advanced security. So with a click of a button here, I can turn on GHAzDO for this entire project, or the same sort of page exists at the organization level as well. Plus, if I want to, I can also click this button. So if I create any new projects or repos, they will automatically get enrolled and protected with advanced security. Once I do that, if I look at my list of repos here, I just have a single one in this project, but you'll see there's this little icon here letting me know that this repo is protected by advanced security. So I'm going to go ahead and click on this guy and make my screen just a little smaller so you can see the whole thing. There you go. You'll see here I have advanced security is turned on. Just for the part of this demo, I'm actually going to turn it off so you can see exactly what it looks like. And when I do, you'll notice that I'll always get this sort of pop-up that's going to let me know about the billing for advanced security. So this is an add-on feature within ADO, and it's not included with the basic license. Instead, the way it works is we look at the number of active committers of your projects. So we'll say, where is advanced security turned on? And then ask the question, how many unique active developers have pushed code in the last 90 days? And that's what we call our that committer count. And that's how we actually do the licensing for it. So me as a developer, I've committed code to a bunch of different repos and projects. So basically it's saying that I'm already covered by advanced security. So there's basically no new charge associated with turning on advanced security in this location. Likewise, it is also prorated, and sort of like if I leave the organization, you stop paying for me. If I turn it on, here we're towards the end of a month, I'll only pay for the few days in this month. So it's really a sort of a pay-as-you-go pricing model, and it bills directly against the Azure subscription that's attached to your ADO organization. So any discounts and things like that automatically apply, which is a nice feature. So I'm going to go ahead here and turn it on. And again, you'll always get that warning. So, if you are always curious of like, hey, how many committers I have, you can always click this button, get that count, and hit cancel. And you're not going to be billed for anything, but it'll give you an easy way of sort of checking the number of committers that you might have. Many organizations I see when they're first getting started might choose, a repo or two to sort of do some testing on. And then once they're happy with that, might move and do it at the organization level. Once I do that, that's really all there is to do to turn on advanced security, really just a couple of clicks of a button. And there's not really much configuration here. There is a way if you want to turn on and off the push protection, but by and large, I would just recommend leaving it on so that you're making sure that at least your developers are getting some sort of a notice before they accidentally push a secret into your repos. So first off, I do want to show what that secret scanning and secret protection might look like. So I'm going to create here a new quick tab, and I'm going to generate a personal access token. Really quick here. I'm going to give it read access, do my live demo here. I'm going to create it and copy. Good thing you can't see the whole thing. And don't worry, we are going to delete it. So if you're watching this recording, don't think you can pretend to be me. So anyways, I'm going to go ahead and take that credential that I have. Again, I can use a wide variety of different secrets. This just is one that's kind of easy to generate here. And now I'm going to actually try to check that into my code. Doesn't matter where in my code I put it. Doesn't even have to be in a code file. It could be, I'll just actually use a markdown file here so I don't break anything. And if I try and actually come in here and edit this file and check in this secret and hit commit here, what you'll see is that Advanced Security is going to kick in and let me know here that it found an ADO personal access token. It'll show me exactly where in my code it was able to find that secret. And it'll also give me a link here that I can go to look at to find more information about what me as a developer might need to do to sort of resolve this problem. So in my case, I might need to amend my local commit history to remove the secret before I would check it and push it up to the server. So this sort of protection, again, you're seeing it in the UI here. Most developers, you're working inside an IDE. You'll get this exact same message. It's just going to come, in the form of an output on your terminal rather than this sort of UI pop-up. I do want to mention really that the secret scanning, as I mentioned, is very accurate in the detection. So if I look at this secret here, and I'm just going to pick a random character here, and I'm going to change that lowercase a to a capital A. So I'm just going to make literally a single digit change there. And if I go ahead and commit this, what you'll find is it goes through just fine. Our engine is accurate enough to be able to detect that this is just a random string of data that happens to live in my code and not an actual secret. So that's a really nice feature there too. I am actually going to check in the real secret in my code. Again, I wouldn't ever do this in a real production setting, but we're going to do it today just so you can see what would happen and the sort of experience that you would get and what the findings will actually look like. So I'm going to go ahead and commit this, but there is a way I can bypass the push protection. So if I type this skip secret scanning : true, what that will do is it's going to temporarily bypass the push protection for this single commit. So think of it as kind of that are you really sure button. I got the alerts. I can modify my commit message if I do need to check in this secret. So reasons you might do that, that rare false positive that maybe happens, or maybe more likely, I have a legacy application where credentials are still hard coded and it's rotating and, I don't want to break my application. So we do have this sort of break glass mechanism there if you are to ever need it. So I'm going to use that right now and go ahead and push the secret. Once I do that, it will sort of let me check it in, but it's still going to generate a finding for Advanced Security that I can go and view. So I'm going to open up here. If I look underneath repos, once I turn on Advanced Security, there's a new section here called Advanced Security. And if I open it up, you'll see I have 3 different sections from 3 different pillars, the dependency management, code scanning, and secrets. So we're going to start here with secrets. And if I refresh my screen, there we go. You'll see just now it detected that personal access token that I just added into my repo. So I can open up this guy and you'll see I have a sort of a finding view for this particular vulnerability. So in this case, it's able to show me where in my code this is and give me a little preview of it. Let me know the exact commit it was added. And it'll give me some more information about what I would do to actually remediate this problem. So in our mind, once a secret has hit your source code, we should consider it compromised or potentially compromised. So even if I were to go ahead and make a new commit that removes this secret, it's still going to live in my Git history somewhere that someone could be able to go and pull it down. Even if I force push over my history and rewrite the history to remove it, someone still could have checked it out locally at some point and had a copy of it. So in our mind, the most secure thing to do when you detect a secret is to really rotate the secret and then go ahead and revoke the one that you had sort of exposed in plain text. Of course, always important to rotate it first. Presumably, it's used for real production reasons. So you just don't want to just necessarily revoke it and potentially break something in your live environments. So I'm going to go ahead and do exactly this right now. That's why I did this in a separate window. So I can go ahead and revoke this token. In my case, I don't really need to rotate it since it wasn't actually being used for anything. Once I do that, we will also recommend it's still a best practice to make sure that token wasn't used for anything unintentional, just to make sure that it wasn't utilized. So in my case, I'm just going to skip that for today. But now I am going to go ahead and mark this alert as closed. And the way we can do that is, again, right within Advanced Security itself. So we have sort of this built-in workflow. So if you look at the top right here, I have this button called Close Alert. And I can go ahead and click on this, and I can say, basically, why am I closing out this particular finding? So in my case, I'm going to go ahead and say it was revoked because that's what I did. But if I wanted to, I could also mark it as something that I'm accepting that risk, or flag it as an inaccurate detection. And I can also leave a comment here to explain why I'm taking that particular action. So maybe I would, say, this person's signing off on it and why, this secret's okay, or whatever justification you'd like. That would sort of capture this as a sort of in your audit trail. So you know why this particular action was taken. So I'm going to go ahead and close out this alert. And I'll note right now that this button up here is controllable. So you might not want the average developer to be able to go in and close out alerts or make that sort of, exception judgment of whether or not this is an acceptable risk. And the way I can do that is just standard RBAC inside of Azure DevOps. So if you're familiar with that, if I come into my project settings again, under repos, if I look at the security section, you'll see there's sections here for advanced security to control who has the ability to view alerts, who has the ability to dismiss alerts, as well as who can sort of manage settings, basically just turning on and off advanced security. So if you want, the default is sort of contributors can view, project administrators can dismiss alerts, and then project collection administrators can manage settings. So that's the sort of default behavior here. If you see, if I click through these, but you can always modify that to meet your needs. So maybe you have, an AD group or enter group. That's, all of your security team that you want the people who are signing off on those sort of decisions. I could give them permissions in here if I have that group to be able to sort of dismiss alerts. And I could even take it away from administrators if I don't want, the development team doing it themselves too. So fully customizable to meet your needs, and definitely recommended that you don't just give everyone permission to dismiss alerts, because people have a tendency to sort of click the button to mute rather than necessarily going through and fixing it themselves.
Hey TJ, can we jump in and answer this question from the YouTube chat I see? It's asking about the remediation path of revoking secrets and what that means in terms of key regeneration versus revocation.
Sure. So yeah, at least, I mean, that's going to depend, I guess, a little bit on the system where this secret is being generated. So in this case of, in my personal access token here, I would basically, if there's a button where I can rotate it, where it'll basically generate a new key that I could then use wherever that token is utilized. And that will then let me then go and revoke the old token. So the exact process is going to sort of depend on the system where the secret is defined. So I would always check there. So yeah, in some systems that would certainly could be called sort of regenerate rather than rotate or whatever. So language could certainly vary, but yeah, I would recommend just checking the documentation of whatever system you might be using.
Thanks, TJ.
Going back to the secret page here, what you'll see here, besides that one thing that we just pushed ourselves, there's other secrets that were detected in this repo. So the first time I turn on advanced security, it's going to do a full background scan of all of my commits, across all different branches. So if it's ever been in my repo, we're able to detect it. So this is a repo I imported in from an open source project. So there you can see various commits here for, many, many years ago. We're able to still pick up those as well. So in this case, I can see I had another ADO personal access token. Here's a GitHub personal access token that's in the code somewhere. So we can detect a wide variety of different secrets there. But no, yeah, it's not just that sort of active protection. There's also sort of that retroactive scan as well. I do also have that sort history. So if I look at the here, I can change this to closed, and I can see here's that personal access token that we closed out just a couple of minutes ago as well. We also are able to detect other things too. So we've recently added in the ability to detect what we call non-provider patterns. So think of this as a secret that isn't being generated by a third party. It's being generated by yourself. but it follows some sort of standard regular format that we're able to build a detector for. So this covers things like here's a database connection string that it's found here in a URL. It could cover things like a JWT, certs, a couple other different types are other things that we're able to detect as well too. So know that's an option there as we're looking to sort of continue to expand out the number and type of secrets that we're able to detect. So that's it for secret scanning. I do want to mention what the dependency and code scanning sections look like as well. These guys, you'll notice I have a bunch of findings in here, but I will note the first time you turn on advanced security, there's not going to be anything in these particular tabs. Instead, you'll get a message saying that you need to set up a build to be able to do these scans. So as I mentioned during the slide section, our dependency scanning and code scanning actually happen at build time or at compile time, so that we're able to sort of increase our accuracy of detection. So for that reason, you do have to add some tasks onto an Azure pipeline if you already have one, or write a new Azure pipeline for that detection. In my case, I've actually already gone ahead and done that, so that's why you saw some results there. But I do want to show what that pipeline looks like. So I have here basically a YAML-based pipeline, but if you're more familiar with the classic pipelines, it works there just as well too. And this, as you'll see, is set to run off of every push to my main branch. I also have this as a build validation policy, so it's going to run on every PR to that branch as well. But yeah, really, when you run the scan, it is sort of up to you. And the sort of minimal version of a pipeline is going to follow these basic steps. I'm going to have an initialized task, then I'm going to run my build. In this case, it's a Java project, so this is a Maven build. And then I'm going to run the scans, so the static code analysis or CodeQL scan and the dependency scanning. So that's the basic flow. So I'm going to need to add, if I have an existing build, basically 3 tasks. Initialize before my build, and then the scans sometime after my build. These latter two don't have any settings to them. You just have to put in the commands. This first one does have some configuration to it. So in my case, it's already written. But if you don't know the actual sort of formatting for this, you can always just look at CodeQL, and I can look at the task here. And we'll give you sort of a UI to be able to fill out the form to run the scans. So the only thing that's required here is the language to analyze. This is a multi-select list of the languages used in my project. It does include other things as well. So for example, JavaScript is going to cover things like TypeScript or other things that compile into JavaScript. Likewise, C# covers .NET, etc. So you would just basically select whatever is the most appropriate for your particular project. And then that's the only thing that's required. But the other one that I'm most likely to use is this query suite. And I like to think of this as sort of a knob that's going to control the number of findings that are going to come back from our engine. The default is security extended, and that's going to run basically our high confidence scans for incidents of all severity types. So criticals, highs, mediums, and lows are all going to come back. So if you don't set anything, that's what you're going to get. If you find that to be a little noisy, maybe you're an organization that only really targets those criticals and highs, that's what this code scanning option does. It's just the criticals and highs only. Or if I want to get additional findings, I can come down to security experimental. Adds in like lower confidence patterns. So think I might add a bigger net, but it is going to increase my false positive rate potentially. The last on the list, security and quality, adds in some like code smell things. So not strictly security related, but some additional filters that we can put in place as well too. I will say we're not, by definition, a quality tool. We're really more in the security space. So you might still want to do linting and other things that you might already do in your existing builds. So those are the only two that are really required. The other one I'll mention here up top is this enable installation. So by default, CodeQL is actually something that has to be installed on your machine to run. It's pre-installed on all the Microsoft hosted agents. But if you are using your own agent infrastructure, you'll want to click this box that's basically going to install CodeQL on your behalf. That's really good for sort of short-term testing. I would say longer term, it's probably easier to build it into your images itself. So if you're using like an auto scaling group or something like that, just to save time so it doesn't have to download and unpack the thing every time. There are a bunch of other settings here. So I probably won't go through this too much for the sake of time, but no, there's a bunch of other configuration that you can use. So like, for example, if I don't like these packs, I can customize them to my own needs. So I can, remove a query, add a query. I can even write my own queries. So you can sort of configure that. Or if I want to exclude particular areas of my code, there's lots of different settings here. But by and large, I would say most people are happy just choosing the language and the query suite are the two main things that I'll see. I will mention this build mode one. This actually is manual is the sort of default. None is useful when you're not actually running a build inside of your image. So like, say I'm doing a build in a lightweight Docker container or something like that, that's not necessarily on the agent itself. I can select something like none for that scenario, where it's able to basically scan through my code and it does its own sort of internal compilation to make that happen. Again, by and large, just set your language and you'll be good to go to get started. And yeah, certainly all the rest of the options and things are detailed in our documentation, which we'll make sure to link here at the end. So once I have that build, again, initialize, scan, or build, then the scans. Then I will start to see things show up in the Advanced Security tab here. So in this case, I'm looking at the dependencies. So this is, again, all those open source components. And you can see I have a large list of things in here since this is that intentionally vulnerable project. But maybe it's a little bit too much for me to sort of start, and I'm not sure where I want to go. So we do have some options up here to sort of sort and filter things to make it easier to find what you're looking for. So maybe I heard about Log4j in the news. I'm curious about if I'm using that. I can just sort of search in here for Log4j. And yep, I guess this particular repo is clear. But maybe if not, I could just do things like say like, hey, let's just look at all the criticals as an example to know where to sort of start my remediation. So I'll just open up one of these. It doesn't particularly matter. I'll just grab this guy. And on these, you're going to see the similar sort of idea to what we had with the secret scanning findings. So we'll have right up top the recommendation, which is this particular package I'm using, I guess Spring Security Config. I'm using version 6.1, and it's saying that there's a known vulnerability there, and I need to update to version 6.1.2. So that's sort of the most important piece right up front there. We do give a location of where this is actually specified in your project, and we'll give you a little bit of a description here as to why we think this is something that should be fixed. If you're looking for more details or want to know like why we're calling this a critical, I can always click here to open up the advisory database. And this is going to go to the raw database where all these vulnerabilities are defined within GitHub. So in this case, it'll tell me all of the different effective versions of this library, when they all got patched. We'll show you the CVSS metrics, which will say like why we're ranking this thing a critical and the exact scores. Link to the different CWEs, links out to the NIST database, or here's things from the actual authors of the Spring framework detailing this error. So it'll give you all sorts of other information that you might want to go look at to sort of help you understand what this particular vulnerability is like. Or if you're like me, I'm just happy to know that, hey, look, I just need to update this number. You're welcome to do that as well, too. In this case, as I mentioned, we're able to not just detect things that are defined in your Maven POM files, but actually all the packages that are getting pulled in. So in this case, if I look on this right side here, I can tell that here's a vulnerable package I'm using, but it's actually letting me know that the root dependency, so this is what's actually pulling in this library, this is what's defined in my project, is actually this Spring Boot Starter Security package instead. So as a developer, I can sort of make the determination here. Do I just want to sort of like pin this particular package to version 6.1.2, or do I want to update the root dependency? Sort of the choice is up to you there of what's the best way to resolve this particular finding. Again, it's going to sort of the specifics will depend on the language of your project here. You'll see up top, I do have that same sort of close alert button as well. You'll notice here there is no sort of fixed or revoked like I had for secrets. And the reason for that is we're basically able to detect when this vulnerability is closed. So basically, the next time you run your build, we're going to run another scan, and we'll see whether or not this library was removed from your project or updated in your project. So if you do, it'll basically go through, detect that, and automatically close out the associated alerts on your behalf. So no real need to do that, which means that me as an average developer shouldn't necessarily need to come in and click this button normally. But we do have that still saying the false positive or risk accepted options if I want to flag this and sort of leave that note as to why I want to remove it off of my active list. So that's the dependency scanning. You'll see I have a bunch of others in here. They're all going to follow the same general sort of format. The information you get here, is going to be a little bit different. It comes from the packages themselves. So know that there's some different options here. The other component I mentioned, code scanning, same general idea here. I have the same sort of filters up top. But these guys, I'm going to open up one of these because there is a lot more information in here. So I'm going to pull up this one. This is a SQL injection attack. And if you're not familiar with those, that's basically where you take data from a user, maybe from a form or a field that they fill out, and use that to build a database query. And if a malicious person was in there, they can basically put in a semicolon and write, an arbitrary command of their choosing to run against your database that, you're just going to go and sort of blindly execute. So a potential really big sort of problem. But maybe your developers don't know what a SQL injection attack is. This is basically going to give you a description that'll tell you exactly what it is. And we're going to give you some more information here in our recommendations as to, what's the right way of sort of remediating this sort of problem. What's the right pattern to use instead? We'll also give you examples code in the language of your project. So in my case, it's a Java project, and it's saying basically I'm doing this bad thing where I'm basically concatenating strings together. And it says instead in Java, the best option is to use this sort of prepare statement set string pattern, where it'll basically sanitize the inputs on my behalf, since this is a really common problem. So I don't have to write all that code myself. So these go on for a long way. So there's going to be examples of multiple different ways you might be able to solve this with different sort of libraries or mechanisms. Again, language specifics here. And yeah, we'll also give you some references down below too to show you, for example, here's a link to an OWASP cheat sheet telling you about this problem, giving you tutorials in Java of the right patterns to use, and links to the CWEs associated with this particular problem. The goal of these is to really give your developers all the information they need, both as to what the problem is, why it's important, and most importantly, I guess, how to fix it. The hope is that when they go through and look at this, that they're going to be able to not only find this problem, but now actually be able to go in and fix it. And maybe even more importantly, be less likely to sort of write this sort of type of vulnerability again. And again, I'm showing this in this sort of advanced security view, which is great if I'm sort of an engineering manager, security person, and I'm looking at sort of a backlog of my projects. But I want to show the way that developers are most likely to interact with these sorts of findings. And that's when they're writing code themselves. So what I can do here is, let's pretend I'm a developer. I was tasked with writing some new function. I went ahead and did that already, and I've opened up a pull request to try to merge in my code. So if I look at this pull request that I have here, what you'll see is I have a new file that I've added in, that adds in some new queries or whatever. And this is using, another one of those sort of SQL injection attacks we just talked about. But as a developer, I just checked in the code. My builds ran, and what you'll see is down below, if you're used to like other members of your team doing like a code review where they might leave like feedback on performance issues or whether or not a particular piece of code meets your requirements, advanced security is going to use that same sort of mechanism to leave a comment right on your code, so that your developers, right once they're writing it, will be able to get that sort of notification. So I'm going to see here that here's that query I'm writing, the exact line, and advanced security has basically added a comment here letting me know, hey, look, there's a new SQL injection attack here. So that developers, while they're still sort of in the flow of actually writing on this new functionality, are going to get that feedback. So they're able to sort of go in and fix these problems there. And this should feel really familiar to most developers. If they're used to any sort of code review, this is just going to feel like another team member on your team that's sort of automatically looking out for you and thinking about these sort of security concerns. So this is a really powerful way to be able to sort of get that notification to your developers and make it really easy for them to work with. So this is showing, again, a code scanning finding. I would also see things here just the same if this was a dependency finding as well. So if I introduce a new library, that would also get flagged here. So it makes it really easy for me to see that. Plus, if I'd like, I can optionally sort of block users from proceeding until they fix these problems. So I can either do that by, in my build validation policy, I can say, hey, look, all these comments have to be marked as resolved before I can merge in my code. That's useful because it'll cover not just advanced security, but other code review findings that other team members might be leaving. Or if I want to get a little bit more strict on it, I can actually put like a gate. So I can add a task at my end of my build that's basically going to fail my build if I'm adding in new vulnerabilities. So in this case here, it's saying, hey, look, I detected a high severity incident, and that's why it's blocking it. And you can configure that task how you'd like. In this case, I'm actually using a custom script here. Oops, sorry. To do that, where is it here? There it is. It's actually basically running a PowerShell script here that's actually using the APIs underneath the hood for advanced security. So everything I've shown in the UI is also available via API. So what this is doing is it basically pulls all the alerts on my branch, on my target, calculates the deltas, and then looks to see whether or not any of those are, in this policy. So basically this policy here, I can change to saying like, hey, like it's going to block on critical size, mediums, and lows, or I can sort of edit this to meet my needs. So this is a sort of a sample script we have. It's available in aka.ms/GHAzDO-resources. We'll get the link to you here in just a minute. But this script and a bunch of other resources are available there if you want to use that to do some customization. Or I think we're also working on building a task in a marketplace where you can just drag and drop this and sort of configure it without having to write any of this custom code. But I did want to mention this because it's a good point to talk about all the APIs that are available as well. And that's for everything from being able to get alerts, close alerts, as well as like turn on advanced security. I can even get like who are the users of advanced security, all that license estimates are all available via API as well too. So that's a little bit of how a developer might work with this. As a security professional though, maybe I'm looking at, what's the overall health of my security program across my organization. And we're also trying to make that easy to do right within Azure DevOps as well. So if I go back up, I'm going to do it on a different tab here, just so I don't lose that, into my organization settings here. We've added a new section called Security Overview. And what this is meant to do is sort of bring a lot of that information from all those individual repos that I might have and bring it to a single screen here. So I can look here and see, here are all the different repos and demos that I have and all the different findings I have in here as well. I can also look at coverage and see, where in advanced security might not be turned on as well. And where I think we'll mention, we have more improvements coming to this screen in the not too distant future. Another option, if you remember at the beginning, I mentioned that we integrate in with the rest of the Microsoft security solutions. So I can also, if I'm interested, plumb all of these findings directly into Microsoft Defender. And make it so I can see sort of a single pane of glass view of not just things, in my application security, but maybe, running resources I have in Azure, to be able to sort of get that single pane of glass view. And what I can do here is basically we add in a section called DevOps Security. And what I would have to do is I would add environment here, link to ADO, and then it will basically import in all the findings, it pulls on a periodic basis. I'll note too, this also works for GitHub. So if you have the GitHub version of Advanced Security, you can also pipe those in here as well. I will say, I saw a question a little bit earlier. I'm showing this on the ADO side. GitHub Advanced Security started on GitHub. It's also available there. Again, the experience is a little different, but the engine itself is the same. I think we had a Reactor series video about it before. We'll see if we can't get the link for you for that if you're looking for the demo of it on the GitHub side. Basically, you're going to use whichever version of a product based on where your repos happen to live. But either way, wherever the source of those findings, I can pull them in here and get this sort of single dashboard to look at all the findings I have across my organization. I can even see, here's an org and all the different repos and the status of them. Or if I want, I can even open up a workbook here and look at more data. So I can say, like, for example, let's look at all the secrets in my org. I can see what, where my secrets live and what different repos, what type of secrets I'm detecting inside of my environment. And if I want, I can even get a raw list of all the different individual secrets. So I can see the source, organization, project, repo, and then the actual secret itself. And yeah, I can actually, it's off the screen here, but a link to actually go into the raw system to see that too. So me, if as a security manager, I can be able to sort of get these reports and roll them up to my CISO or anyone else in my organization who might be interested. So that's another option as well. And all this, everything in the Defender side for advanced security here, there's no extra charge for any of that. So it could be a nice way, especially if you have multiple different organizations, to be able to sort of consolidate all of your findings into one place. So that's advanced security in a nutshell. I went through the three main areas and a little bit on reporting. And now I'm going to actually hand it over to Laura. And I think she's going to talk just a little bit about for roadmap. And then, yeah, we'll make sure we go through and answer any questions as well. Let me get to the right slide here.
Perfect. Thanks, TJ. I also wanted to just address the two quick questions in the chat here. So I see one around clarifying the level of access needed to close secret alerts. You will require the advanced security dismiss alerts permission. So we have a particular permission in repo settings or the project level settings, which you can then define and assign to a security group or user to grant them the right permissions to dismiss alerts. So that'll be the same permission regardless of the alert type. So you will need that to dismiss dependency, code, and secret alerts. It's a one permission for all alerts right now. The second question is around release pipeline permissions. We do have a separate documentation page for that around release permission pipelines. So I won't spend too much time answering that, but I can look to share some documentation or a link to that documentation around the permissions model there for pipelines. I see a new question just came in as well around, is advanced security available in the Azure Government Cloud? Unfortunately, today, GitHub Advanced Security for Azure DevOps is only available in the public cloud right now.
It also does not include Azure DevOps Server, so only cloud today.
Thanks. All right, so let me briefly cover our roadmap. I'll cover what we shipped, some big ticket items in the previous year, and then also covering some of the big ticket items that we are planning on shipping in the first half of 2025 coming up. At the top of the list is the ability to shift left more in your security. So as TJ just demoed, we introduced pull request annotations for your dependency and code scanning results to help you and your developers understand when you're introducing security debt and be able to address that even sooner than after pipeline scanning once the result has already been introduced. Secondly, for dependency scanning, we also introduced the ability to have commit list builds to receive new dependency scanning alerts. What happened in the past is that customers were required to run a pipeline build and also include a new commit present for dependency scanning to then register new dependencies and potential vulnerabilities. Now you can just run a scheduled build, say every day, and you'll receive updates on new vulnerabilities associated with your components upon every pipeline run moving forward. In the code scanning sphere, TJ also demonstrated briefly the build list extraction for C# and Java. And again, this helps simplify some of your scanning processes if you're using pipelines for the CodeQL task today. All right, so let's briefly cover what we're planning for 2025. In the secret scanning space, we have a really exciting feature around validity checks. And what this does is that it enhances the kind of metadata you can get when you're looking at validating, is a secret alert actually worth my time right now to prioritize versus can this kind of go on the backlog to figure out in the next couple of weeks or months for my developers team. What this will do is it'll add a new badge on the secret scanning alerts tab to each individual secret alert that's been created for the provider partner patterns. If we can, we'll attempt to check the validity of the secret, or in other words, say, is this secret currently valid and live? What this means is that you, as an AppSec team or developer, can immediately prioritize the things that are currently live and going to produce real tangible risk to your enterprise, and focus on burning down the valid secrets first. Next up is also ways to make enablement easier so that you can enable advanced security more broadly and at scale for your organization. In the next few weeks, you'll start to see a new enablement setting for dependency scanning in the repo settings view, where you can click the checkbox and you'll automatically get dependency scanning injected into your pipelines that are targeting the default branch in your repository. For dependency scanning, this is pretty straightforward. And we are also looking at ways to make one-click enablement for CodeQL easier as well in the coming weeks and months. So keep a lookout for that in release notes or in any potential preview states. TJ also hinted at some improvements coming up to security overview pages. So we're hoping to make those a little bit more action-oriented for AppSec managers to use today. While on the risk side, it's currently severity oriented, so it's a breakdown of alerts across different severities. In the next few weeks, you'll start to see different data pieces come to play in the risk view. So you'll be able to see new alerts that have been generated in a certain time frame, fixed alerts, dismissed alerts, and also total active alert count. You will still be able to filter by severity as well, so that will still exist as a touch point. And then you'll also be able to filter by tool set. So whether that's dependency scanning, code scanning, or secrets, you'll be able to filter down to that specific view that you're looking for. On the coverage side, we're also enhancing the coverage page to be more specific. So instead of just seeing an overall enablement status for advanced security all up, you'll be able to see the specific breakdown for dependencies, code scanning, and secrets. So you'll see the availability of dependency scanning alerts, pull request annotations, the same for code scanning alerts, pull request annotations, and then for secrets, secret alerts, and secret push protection as well. Lastly, I also want to highlight some really important glue pieces to help with remediation and putting the pieces together between receiving an alert and acting on these kinds of alerts. Our team is working on integrating with work items on the Azure DevOps board side, so you will soon be able to link an Azure DevOps work item, whether that be a bug or a feature, however your organization is deciding to tackle these things, with an advanced security alert. It'll be bidirectional, so you can add it from the alert side and also from the work item side. Another really great integration that we're adding into Azure DevOps is notifications by integrating into Azure DevOps service hooks. We'll be adding a couple of different features here, but you'll be able to get custom notifications or create webhooks, integrations with different applications, etc., all out of the Azure DevOps Service Hooks framework. When you get a new alert, when alert data changes, or when someone has fixed or dismissed alerts. There's plenty of different customization options available in there as well, so there's probably some way to customize it to work with your organization and your notification settings. Overall, I think we have a lot of things planned in the first half of 2025, so I hope that you'll give Advanced Security here a try and also provide us any feedback on any of these upcoming features, or let us know if there's anything that you're looking forward to that you don't see on the roadmap. I think that's all I have. TJ, do we have any other slides? Oh, you're muted, sorry. TJ, you're muted.
Sorry. Yeah, I would say I do have a couple of things, but one, I would say, Anna, if you could drop that dev community link in, that's the best place if you have feedback to leave for advanced security, or certainly work with your Microsoft or GitHub account team directly as well. But since we have a couple of minutes left, I am going to show one more thing that I sort of skipped for time earlier, and that is the ability to sort of bring in other findings as well too. So one thing you might note is that advanced security, that language list doesn't cover everything. So it covers most of the main sort of programming languages, but the key things that we see that a lot of people ask about is things like infrastructure as code. So think of it as Terraform or CloudFormation or an ARM template, those sorts of things, or container scanning. And that's where we can actually bring in tools from a marketplace instead. So I didn't scroll down far enough on this list, but you'll see I can actually bring in third-party tools as well. So you can use things like the Microsoft Defender has a great task that brings in a whole bunch of different other scanning tools. Or in my case, like I've picked one particular scanning tool here called Trivi. That's an open source tool for infrastructure as code and container scanning. So any of these extra tools I can run them in my pipeline and then publish the findings into Advanced Security. And then they're going to behave just like any other native finding. So that same sort of annotations on my PRs are going to show up. They're going to show up in my Advanced Security view as well, to make it really easy if you need to integrate in to cover things that CodeQL might not handle today. So yeah, just an example you might have seen up top here. Here's some for infrastructure as code, where it's finding, for example, here a security group that's wide open to the internet as an example here. So that's also another thing too, if you want to sort of bring in more functionality to Advanced Security. So that was one thing I skipped for time, but definitely happy to take any other questions. I know we've got a couple of minutes left. Otherwise, I'll hand it back to Anna to close this out.
We can move on to the survey, and we can keep it live so that if y'all have any questions, you can feel free to drop them in the chat, and we will hang out in the chat for another couple minutes. So thank you, everybody, again, for joining. We are a part of a series. If you would like to watch past episodes on demand or register for future shows, you can follow that link on the screen. It's also in the chat. And if you have a moment, we're always looking to improve our sessions and your experience. If you have any feedback for us, we'd love to hear what you have to say. You can also find that link on the screen or in the chat. Today's event code is 24803, and we'll be hanging in the chat if you have any more questions. We'll see you at the next one.